The purpose of looping in a macro is to repeatedly generate code. But first, there is a simple way to do it without a macro. You can use the times assembly language operator to cause an instruction to be assembled a number of times. This example is exactly the same as if you had typed in db0 64 times. Now the constant value can include defined constants and can be made up of an expression. All it does is repeat the one instruction. These two instructions have exactly the same result. They both declare a block of storage of 50 bytes. You cannot use the times instruction on a macro, however, because the macros are expanded before times is executed. That's so you can use expressions with macros in the constant expression. But there is a way to repeat a macro, or anything else. You can repeat entire blocks of code using the preprocessor. Here's an example. The REP and end REP instructions will cause the code between them to be repeated the number of times specified in the expression on the REP operator. This is a simple example, but you can do a lot of things by using it with other preprocessing directives. Remember that the assign directive assigns a value to a symbol, and it can be used repeatedly to change that value, and it can be used in an expression to derive the value to assign to itself. Now, in this example, the symbol index is set to 0, then it's incremented by 4 each time through the loop. The result is that the code generated is a series of increment instructions, so that a 1K table containing 256 32-bit integers has every integer incremented by 1. The important thing to remember is when things get executed. You have to keep it in your mind which things occur at assembly time and which things occur at runtime. Now these things can get a little hard to keep straight. Here's an example. This sequence of code generates DW, defined word declaratives, that contain all the Fibonacci numbers that will fit within 16 bits. This example uses something new. The exit REP command will immediately abandon an REP loop. This also shows that you can use if and endif inside a loop. The assign statement is used to manipulate the values in the variables I, j, and k. The important thing to remember is that all this looping and all the calculation takes place in the assembler, not when the program runs. And you can put a loop inside a macro. This macro is defined to accept any number of arguments from 1 up. That's because the upper range value is an asterisk, which means unlimited. It pushes all the arguments onto the stack. The number of times a loop is repeated, %0, is the number of arguments supplied to the macro. What's new here is the rotate command. Specifying rotate 1 shifts the arguments 1 position to the left, and the argument that is shifted out of the list is inserted back on the right, so no arguments are ever lost. You rotate to the left any number you'd like. Using a negative value to the rotate command moves the arguments to the right. Of course, this push macro needs a complementary pop macro. This macro will take the same arguments in the same order and pop them back off the stack. Again, you see the number of arguments on the REP command. The rotate command comes first and has a count of -1, which means the arguments will be rotated from left to right, with the rightmost argument rotated back to the left each time. The pop command then uses the leftmost argument as its value each time, so the items are popped off the stack in the reverse order they went on. So to use these two macros, you supply the same arguments in the same